So take a look at these other potentially useful coding conventions. You'll notice that they provide useful information about wind, beginning and ending times of precipitation, lightning, precipitation amounts, and also minimum temperatures over 3 or 6 hour periods. So let's work through some more examples in order to get the hang of how to decode these sorts of conventions. Okay, so here's another METAR example. So do you remember what the first piece of information given by 4 letters, KSFO in this case, represents? KSFO. Well, that's the 4-letter International Civil Aviation Organization code, where the weather was observed. So you'll probably recognize KSFO as the code for San Francisco International Airport. So that is the location. Then our next piece of information is here, 160800Z. Remember that this tells you about the day and time that the observation was taken at. The first 2 numbers, 16, are the day of the month. And then the next 4 numbers are the 24-hour time in Greenwich, England, also known as UTC, GMT, or Zulu time. Right? That's what the Z actually means, Zulu. So this observation was taken on the 16th day of the month. Remember that the METAR itself doesn't specify which month it was, at 0800Z. And this would be either midnight or 1 a.m. in San Francisco on the 16th, depending on whether Pacific Standard Time or Pacific Daylight Time was being observed. Okay, our next piece of information here is 21004 KT. And you'll probably recognize the KT stands for knots, and that's a clue that this piece of information is telling you about wind. Right? So if you don't remember right away, you look at this and you say, oh, KT, that looks like knots, right? So the first 3 numbers are direction, 210. So the wind direction is 210 degrees. And if you go back, pause and go back to the wind rose, you'll see that this is south-southwest. So that's the direction where the wind was coming from. So it was going toward the north-northeast. So wind direction and speed, 210 degrees for south-southwest. And then the speed was 4 knots. Right, so see 04 KT. That means 4 knots. Notice that for this example there were no gusts. And this makes sense because usually at such a light wind speed as 4 knots, you're not going to see any gusts. Usually you have to get winds of at least 15 knots or so to start worrying about gusts. Okay, so we've decoded the first 3 pieces of information. The next we have 8SM. What do you think that is telling you about? Well, that's telling you about visibility, because the SM stands for statute miles, right? So the visibility was 8 statute miles. Okay, moving along nicely. Next we have dash TSRA right here. And recall that TS means thunderstorm and RA means rain. as the slide about other useful coding conventions hinted at. And what about the dash? It turns out that this dash here means light. So anytime you see a dash like this in front of some information about rain or thunder or snow, it means light. Oops. So what this is saying is that rain was being reported, but it was light, and it was associated with a thunderstorm. Typically, precipitation is either reported as light, moderate, or heavy. Light is given by the dash, heavy by a plus, and moderate doesn't require a special character in front of the precipitation code. So, for example, if just moderate snow, not light or heavy snow, but moderate snow was being observed, you would see SN. Not plus SN or minus SN, but just SN. So present weather is a thunderstorm producing light rain. So to recap, what we have so far is that at San Francisco International Airport on the 16th of the month at 8 UTC, either 12 or 1 a.m. local time, there were south-southwest winds at 4 knots, visibility of 8 statute miles, and with a thunderstorm being observed producing light rain. Then the next piece of information is BKN 020. This is telling you about cloud height and cloud coverage. So the BKN stands for broken, and the 020 means 2000 or 2,000 feet. So there were broken clouds at 2,000 feet. And broken cloud coverage means 5/8 to 7/8 of the sky is covered by clouds. By the way, this would be classified as low clouds. Guys, you'll learn that clouds at a height lower than 6,500 feet are typically referred to as low clouds. Next, we have OVC 100. This is telling you that there were overcast conditions, or another way of saying that is that the sky was completely covered by clouds at 10000 feet, or 10,000 feet. Remember, to get the feet, what you have to do is you have to add 2 zeros to the end of the number. And by the way, 10,000 feet is at a height in the middle cloud range. So broken clouds at 2,000 feet, overcast clouds at 10,000 feet. Okay, the next piece of information is 20/18. And this is telling us about temperature and dew point in degrees centigrade or Celsius. So the temperature was 20 degrees Celsius and the dew point was 18 Celsius. Because they are close together, relative humidity is high. So you'll learn in Met 60 that when temperature and dew point are very close together, that means that relative humidity is close to 100%. And this makes sense for this particular METAR, because remember how it tells us that there are broken clouds at 2,000 feet, which is very close to the ground, right? And there's also a thunderstorm producing light rain. So typically, it turns out when precipitation occurs, the atmosphere is close to or near what we call saturated, meaning relative humidity is high. And that's when relative humidity is high, that means that the air is very close to capacity with water vapor. So if relative humidity is high, that means the air has almost as much water vapor as it can hold. And if the relative humidity is 100%, That means that the air contains as much water vapor as it can hold for that temperature. Turns out the warmer the temperature, the more water vapor that the air can hold. And then we have A2966 here. And this 5-character piece tells you sea level pressure information. Remember that the A stands for altimeter, while 2966 is the sea level pressure in inches of mercury. Excuse me, in hundredths of inches of mercury. So So 2966 means that the sea level pressure is 29.66 inches of mercury. Next we have RMK here. RMK. And that stands for remarks. So following RMK, there's a set of additional statements that are not standard pieces of information for every METAR. So they aren't always included, but in some cases they are. So remarks. CB. Any idea what this stands for? Turns out CB stands for cumulonimbus. And you may remember from Met 10 or a similar GE Introduction to Meteorology class that cumulonimbus clouds can produce thunderstorms. And so it makes sense that a cumulonimbus cloud was present, because remember the METAR told us that there was a thunderstorm observed producing light rain, right? So remember this piece here. I'll underline this again, dash TSRA. And the decoded information is here. Makes sense, because if a thunderstorm is present, then there needs to be a cumulonimbus cloud present, because cumulonimbus clouds, usually only cumulonimbus clouds can produce thunderstorms. Okay, you can probably figure out the next piece of information here. EMBD, D stands for embedded, right? So sometimes decoding a METAR, it's a little like decoding a text message, right? Light LTGCG here stands for lightening cloud to ground. So LTG stands for lightning, and then CG stands for cloud to ground. By the way, and this was on the that slide that had other useful coding conventions. And then SE just stands for southeast. So the METAR is telling us that there was a cumulonimbus cloud with embedded cloud to ground lightning to the southeast of the observation site. Then we have SLP 044 here. And this is another way of representing sea level pressure. And so this is telling us that the sea level pressure was 1004.4 millibars. Remember how to decode this. If the first number of the three numbers begins with 5 or greater, you add a 9 to the front and then add a decimal place in between the second to last and last numbers. But if the first number in this little sequence here next to SLP begins with less than 5, what you do is you add a 10 to the front and then put a decimal point. between the second to last and last numbers, and then that gives you the sea level pressure in millibars. So there's different units for sea level pressure, right? Inches of mercury and millibars. So we have two pieces of information in this METAR telling us about sea level pressure. One gives it in inches of mercury here, shown here, this guy, and then the other gives it in millibars. And then the last sequence of information in this METAR here, T02030184. Now, do you have any ideas on what this tells you? Turns out that this gives a more exact representation of temperature and dew point in degrees centigrade. So following this T, there are 8 total numbers. Excuse me, 7 total numbers. Following the T, there are 8 total numbers. And the first 4 are about temperature, and the last 4 are about dew point. And the first number to the right of the T gives temperature, tells you if temperature is positive or negative. 0 means positive, while 1 means negative. So because there's a 0, this means temperature was positive. And that makes sense because remember how an earlier piece of information told us the temperature and dew point were 20 centigrade and 18 centigrade. So it turns out that this sequence of information gives you a decimal representation of temperature and dew point, while the previous information here just gives you it rounded to the nearest whole number. And the next 3 numbers give the temperature in degrees centigrade with the 10th decimal place included as the last. So what this is telling you is that the temperature was 20.3 degrees centigrade. You just add a decimal place here in between the second to last and last numbers. Then the next 4 numbers tell you about dew point. Once again, the first number tells you if the dew point was positive or negative. If it was negative, it would have a 1, but because it's positive, there's a 0 here. And then what you do to get the dew point is you add a decimal place here, just to the left of the last digit, between the second to last and last numbers. Dew point is 18.4 centigrade.